We want to talk about quality function deployment, or QFD, but to do that effectively, we first have to differentiate it from a very related term known as a house of quality. House of quality is a matrix tool. It's a set of matrices we put together to model and create relationships and measurability between requirements and functionality of a given system at the what and how kind of level going through. So that this presentation is not about house of quality. It is about quality function deployment, which is an analysis process that looks through multiple layers of houses of quality and puts them together to form a chain of reasoning, if you will. So a QFD is an analysis technique that uses one or more houses of quality all chained together according to the phases of your life cycle. In the literature, you'll sometimes see the two terms used interchangeably, but we want to be a little stricter here. As engineers, the house of quality is the set of matrices, and the quality function deployment is what we do to take advantage of them in our engineering. So moving forward from that, we're really talking about deploying the voice of the customer down through the different levels going on. That's why it's called quality function deployment, is we're looking at ways to chain all this through. So it all starts at the top level in the very first house of quality with the customer's critical to quality requirements. And we can put together these different matrices where the prioritized output of each house of quality becomes the new input as rows to the next level of the house of quality, so that when you're done, everything in all the matrices ties all the way back to the customer CTQs back at the beginning. So that's what's meant by quality function deployment. And as you can see, there's a strong relationship between QFD and the houses of quality that make it up. In terms of specifications, typically the house of quality will not document your engineering for you. It documents the relationships among your engineering. So typically before you go from one level of QFD in the house of quality down to the next level, it's important that you formalize your specification. Use some form of engineering technique to decide what should go into our next matrix. So the what's come in on the rows. How do you decide what goes into the columns? So the columns is a separate discussion. There's nothing about house of quality that tells you what the columns have to be in the next house of quality that you build. That's where you've got to do some specification, some formalization of your engineering logic. But assuming that is happening outside or around your houses of quality, the houses of quality in your QFD fit together. So QFD is a good starting point, but it's not just your formal specification in its entirety. You can't just publish your QFD and say, here's our specification. There's a lot more that goes into that, because you've got to have a valid engineering rationale for all those choices of columns. In what way did you as an engineer decide that those columns were how those rows, the what's, should be addressed? So look for that relationship. QFD is not your one-size-fits-all engineering tool. It's about relating, prioritizing, and measuring the things that are going on in that design process. If you go through a series of these approaches, you'll build more and more houses of quality as you work your way down. There's no magic number here. Typically, I use 3 to 4 levels as I go through a system implementation to get from customer QFDs to process requirements to their functional implementation to their system design and to their operationalization. If you have a system engineering lifecycle that you are using, chances are you will want to have a house of quality corresponding to each of the phases you're going to go through, so that you're capturing the output of each of your lifecycle phases. So if you have a 7-phase system engineering lifecycle, you'll probably end up with 7 layers of houses of quality, so that your matrices, your prioritization, your relationships, your quantification, your measures all correspond to that level of detail that's been being dealt with in that phase of your life cycle going through. So typically, like I said, I use 4, but the number is arbitrary. You can use a completely different number as you go through. But typically, I fill mine in with customer needs on the first matrix, and I have functional requirements coming out on the top. So if you're doing a systems level where you're conceptualizing your system, trying to decide what it needs to do, this first house of quality might be all you need during your system or project conceptualization phase, because you're translating high-level customer needs into what you think your system's going to need to do, kind of like a concept of operations type of document. The second stage, you're taking the prioritized functional requirements from that first stage and you're inputting them into the second matrix to figure out the technical requirements for how you're going to deliver on those things. This is more like a preliminary system design or a functional specification type of level to figure out how you're going to implement the things you put into your ConOps in terms of that first level as you go through. And that stuff gets prioritized. It becomes the rows of the third matrix, where now I know the functional prioritization of what I need to build. I might now need to do my design characteristics in terms of how I'm going to deliver all of those functions. Okay, and that will allow me to prioritize of all the things I could do in terms of my hows, what are the priorities going through. And then lastly, I might want to operationalize that. What kind of support does it need? What kind of training does it need? What kind of backup and recovery does it need? But I want to have rows to tell me how, for the key system characteristics, I know how I'm going to operationalize them going through. Again, the 4 layers I just took you through are not necessarily the way you have to do it. This isn't the definition of QFD. It's just an example of how I use QFD in a 4-layer approach to go from customer requirements through the operationalization of my system. So again, like with the house of quality, you should be reviewing the quality as you go through. Make sure in every given level, all the watts get covered somehow by the how. There's no empty rows. Make sure all the hows are justified against the requirements. There's no empty columns, and you're not just arbitrarily translating them from one layer to the next as you go through. So if you do that, come up with that first level of what to how in the planning matrix, your design matrix might then do another layer where, again, the hows from each layer become the whats of the next layer. That's the key to remember. Once you have that pattern down, whether you use 2 layers or 10 layers, the process becomes fairly automatic as you go through. One thing you'll need to do as you work your way down is the output of a matrix gives you a prioritization score in terms of a relative ranking, the prod sum of the priorities and scores in your ranking matrix. So some of the prioritized rankings can be numbers in the hundreds or even thousands. So as you move them down to the next level and fill in your priority, you could, in theory, use the actual final raw ranking from the prior matrix, but then you're only going to get larger and larger scores. By the time you get through 4 levels, your scores would be in the billions. So what you typically want to do is take the score you received from the matrix across the bottom and translate that range of scores into a prioritization for the next matrix down that makes sense. So maybe always normalize or translate your ranked scores to a scale of 1 to 10 or 1 to 6 or something of that nature. But that's just for controlling the math. Because if you're doing this in Excel, you don't want to end up with a 15-digit number on the raw score of the 4th tier. So normalize back to a normal level of prioritization scale, and the matrices are that much easier to use. But that always allows you to take what comes out of one matrix and go into the next. So something that's a column in the first matrix has a raw score of 50,000 from its accumulated score, might be a priority 10 going into the second matrix. Something with a raw score of 1,000 out of the first matrix might go into the second matrix with a relative score of 1 or 2. So you're not changing the order of the priority, you're simply making the math work out better as you use some of these matrices going through. When you're all done, then you now know what your critical to quality variables are for each layer of your engineering process, from the customers up front down through the control of your low-level operationalization. And as an engineer, then you'll take those factors and translate them into the control plan for your system. So you're immediately on day one thinking in terms of not just implementing your system, but making it operational, being able to support it, knowing what the control plan will do for the system seeing its way through. So it helps support a much broader and fuller life cycle than just looking at what a system has to do.